So here's our third video on the series of using an LCD with Arduino Uno. We're using an LCD with the I2C facility available. And as I explained in the previous video, one of the first steps in getting an I2C device right is to find out what its address is. So in this tutorial, we'll be looking at code from Nick Gammon. I've taken it from these two websites. The links would be there on the description box as well. And what this code is going to do is it's going to scan the devices connected to the SDA and SCL line of the Arduino Uno, that is A4 and A5, and print their addresses to the screen. So this enables to find out the address of the I2C enabled LCD that we are using. And once we know this address, we can use this for our future code. So the first step is that we'll be using the wire library. The wire library of the Arduino basically helps in communication with I2C and TWI or two-wire interface devices. I reiterate again the SDA and SCL lines. And an important point that I mentioned in my previous video is that we are using 7-bit addresses in I2C. And the first statement is, of course, include wire.h, since we'll be using this library. Let's pause for a minute and show you the code. So here's the code. So what this code does is that it scans and finds whatever I2C devices are available connected to the Arduino and displays their addresses. So this enables us to detect any number of I2C devices which are connected to the Arduino Uno. So as we saw, we're just having the serial.begin first, and then we have this while loop. So what this does is that as long as the serial is not available, the condition for the while loop remains true. And since there's nothing in the while loop, this basically means that our code waits here. And now if you've been observant, you would have noticed that a few more commands are there in the code. There's wire.begin, there's wires.beginTransmission, and there's wire.endTransmission. I'll be talking briefly about these three statements and then going back to the code. So wire.begin, it's basically to be called once, and it initializes the wire library. Giving an address in wire.begin is optional. If you don't give any address, then the I2C bus is the controller if nothing is given. Then we have the wire.beginTransmission command, and in this it's compulsory to give the address. So this basically starts to queue bytes for transmission to a particular I2C address. So we go back to our code. The first line is including the wire.h library. Then we have the void setup. We set serial.begin to 9600. So this enables the Arduino to communicate with the PC and print on the serial monitor. This I just explained is a while loop which causes the code to wait till the serial port is connected. And once the serial port is connected, then we have serial.print new line, and here we print that I2C scan is going on. We have a byte variable count which is initialized to 0. So byte is basically an 8-bit unsigned value which goes from 0 to 255. And after this we start our wire.begin which initializes the communication, and then we have a for loop. So while the byte value is between 8 and 120, it's going to get incremented. So what's happening here is that I is basically a byte variable, and as we saw in a previous video, the range of addresses is from 8 to 119, and so that gets covered in this for loop. So we are trying to begin transmission to each of these possible addresses one by one. So we are scanning the addresses. So wire.beginTransmission I basically queues up bits for transmission to that particular address. And now if that address is actually there, then this transmission will be successful. If the device doesn't exist, then the transmission would be a failure. So wire.endTransmission, this basically I just explained, returns a 0 if it's successful. So if you're going to get a success here, then this if loop will be true. And if this if loop is going to be true, then we are going to serial print the address that we have found. So here's our setup. As you can see, here's the Arduino Uno. There is a jumper connection to the Arduino Uno. This is the 5 volt power rail, and from here we are also giving the connection to the LCD, to the SDA, and to the VCC and ground, and here's the SCA and SCL going to the LCD. So here's the connections in a little bit more detail. This is the jumper connection. These are the A4 and A5 connections. This is the ground connection. We are grounding the Arduino just as a safety. Then this is the MB102 showing the positive rail and the negative rail. And here's the connections at the I2C device. Now some small information on the serial.print. So if you write serial.print 78 bin, then you will get 78 in binary form. If you write serial.print 78 in hex, you get the same number in hexadecimal form. So with this background information, we go back to our code. So I'll just review this again. So we set up the serial communication. We wait till serial communication is available. As soon as it's available, we start to scan. We initialize a count variable to 0. Then we run a for loop. We begin the communication on the I2C bus with wire.begin, and then we start to scan the addresses. So we go from 8 to 120 because the other addresses are not valid in any case. We begin transmission to each of the addresses. So we're basically scanning the addresses. And if end transmission happens to be 0, that means that the transmission has been successful. And in this case, we find the address and find it and print it out in decimal format and also in hexadecimal format. And we increment the count of the number of devices that we have discovered. And when we reach the end of the loop, we just print the total number of devices that we have found out, and we also print out their addresses. So here we go. I'm ready to flash this code to the Arduino. I select Arduino Uno COM4 from here. So that's it, the code's been flashed. I just turn on the power to my device. It started to scan, but no devices are being formed. I turn on the power to the LCD. There you go. As soon as I do that, the device has been found out at the address 39 or 0x27. So that's it for this video. The point to remember is that whenever we use an LCD screen fitted with this I2C chip along with the Arduino, we would need to remember this address 0x27, and based on this address we would have to take a call on how we write the code. Thank you.